Hello everyone, welcome to my channel. In this video, I'm going to be introducing you to the structure behind a neural network and hopefully cement your newfound understanding with some raw Python code. But first, a little background. With the recent surge in popularity of deep learning, there now exists an ever-increasing abundance of online resources for cracking to the subject. While only a decade ago, it would require a legitimate PhD to learn about and pursue a career in deep learning, this new explosion of public resources, ranging from books, podcasts, blogs, and YouTube videos, has made it so anyone can facilitate a solid understanding of this once exclusive field. But with so many available resources, it can be quite confusing, and oftentimes misleading about where to begin. For example, you'll encounter a plethora of material that claim you need a rich understanding of both multivariable calculus and linear algebra just to begin. And similarly, you'll come across code tutorials written in some high-level framework like TensorFlow or PyTorch, which can also appear extremely daunting to a beginner. However, to understand neural networks at the level at which I plan to introduce them, the only prerequisite I expect is a basic understanding of high school algebra. Similar to many inventions throughout human history, we drew inspiration from biology to ignite the basic principles of a neural network. As the name suggests, neural networks are modeled after neurons and synaptic connections in our brain. As you can see in this example, the light gray circles, or neurons, are connected by yellow lines, or weighted connections. And please note, the colors used in these animations are completely insignificant and chosen purely for aesthetic purposes. Thank you. Generally speaking, neural networks are comprised of an input layer, an arbitrary number of hidden layers, and an output layer. Please ignore the mathematical notation for now, we will get to that soon. In this example, our input layer is constructed of 4 neurons, allowing for 4 pieces of data to be passed into the neural network. Yes, data is passed forward from the input layer to the first hidden layer, which relays data to the second hidden layer, and finally to the output layer, which hopefully produces a desired result. So how and why do neural networks work? Well, each neuron is connected to various neurons in the subsequent layer, and every colorful line you see, every connection, is a unique weight. A neuron accepts, as input, the sum of the outputs of neurons in previous layers multiplied by the corresponding weight values. If this collective input value is above some threshold, the neuron sends its own output signal, which is then received as a portion of an input value by other neurons. In addition, quite literally, every neuron has a unique bias. This ends up giving us a colossal number of uniquely tunable parameters. For example, with a network architecture of 7, 10, 10, 10, and 7 layers, we find ourselves having 384 unique parameters. And it's the sheer amount of numeric depth that makes neural networks so complex, yet so beautiful and highly, highly capable. Please don't worry if this sounds confusing, we're going to break it down in just a few minutes. One goal of a neural network is to take the input data and produce desired output data. For example, perhaps we would like our neural network to be able to correctly classify images of toucans and parrots. While this is an absurdly trivial task for humans, a neural network does not have eyes, so the process of training a neural network to learn such a distinction involves adjusting the hundreds, and oftentimes many thousands, of uniquely tunable parameters. This happens to be the most difficult part of deep learning in neural networks, as devising an optimal strategy to perform this task can be rather complicated. In this example, we have 2 neurons in our output layer, the top a toucan neuron, and the bottom a parrot neuron, and depending on which has the higher value as a result of the forward pass of input data, which in this case would be an image of a toucan or parrot, will represent the neural network's output. So, given a labeled dataset comprised of images of toucans and parrots, the network is trained by adjusting its weights so that when it sees a new, unlabeled image of a toucan or parrot, it outputs the correct label for that image, being either toucan or parrot. Now, we're going to embark on our raw Python code tutorial, for which you can use any text editor you please. Let's say we have a neuron, and there are 5 neurons feeding into this neuron from the previous layer. We don't know much about them, but we do know that each of these 5 neurons possesses some numeric value. These values are their outputs, which serve as the input values for the neuron we are going to code. Let's just make up some arbitrary numbers to serve as our unique values for this tutorial. As I attempted to explain, every unique input has a unique weight associated with it. Because we have 5 input values, we also have 5 weight values. Furthermore, every unique neuron has a unique bias, which will have equal to 7.8. Now, the first calculation for a neuron is to sum the products of all the corresponding inputs and their weights, plus the bias at the end, which is actually an extremely simple mathematical calculation. Therefore, the output value of this neuron is 98.2. And there you have it. We have just successfully coded the behavior of a neuron in raw Python. And see, I hope what I discussed earlier and what I'm echoing now is starting to make more sense. Thank you all so much for watching, and I hope you learned something. This was my first ever explanatory video, so please, feel free to critique my presentation in the comment section below. Finally, I would love to give a special thank you to Manim, the mathematical animation Python library that made this video possible.